WeighWell is a leading supplier of wheel weighing equipment to the railway industry. And ExcelCalcs is an internet website where we encode expert engineering knowledge, we encode them into spreadsheets and spread them through a wide user base. Now, we've been working together on a project and we've come up with a really innovative solution for wheel balancing. And together we can increase rail safety and we can reduce depot costs. But to set the background so that we all understand what we're talking about here, I'd like us for a moment just to think about a wobbly table. I'm sure we've all been sat at them. I'm sure we've all lost a lot of beer whilst we've been sat at them. What happens is the table doesn't become level as it rocks around, and you might get pens rolling off the tabletop. You'll be annoyed by the clatter of the table as it joggles about. Really quite a nuisance for us, but it's easily solved, and it's easily solved using this set of business cards, what we will call packers. Now, if we can imagine taking that same wobbly table and then popping on some suspension elements, sticking it on wheels, throwing a load on its back, setting it upon the rails and sending it whizzing down the tracks, then we end up with a wobbly bogie. And a wobbly bogie will show unbalanced wheel loads. This might give rise to dynamic instabilities like hunting, or it could give rise to incorrect levelling, throwing our vehicle out of gauge. But it's solved in just the same way. It's just a little bit more complicated than packing a table, but we pack primary suspension elements to improve the situation. Now, I think we need to talk a little bit about why we pack, and I'm going to go through some reasons as to why we pack. And the first is really the most important one. We pack to avoid the risk of derailment, and I'll explain a little bit about that now. If we have our bogie, all four wheels sitting on a level rail, then the wheel loads will be the same if the bogie is ideally packed. Then what happens is we will introduce a dip to one of the wheels, and what happens when one of the wheels sees the dip is it loses load. Now, this losing load, or delta Q as we call it, compared to the nominal wheel load, which is Q, has to be less than 0.6 to keep away from the risk of derailment. Anything greater than 0.6 shows a high risk of derailment. Now, if you have a poorly balanced bogie, then you may be starting, before you even introduce a dip, you might be seeing already one wheel load being higher than another the nominal wheel load, and that could be as high as 0.25. So you can see there how we've made it very difficult for us to keep this delta Q upon Q ratio below 0.6 because we're starting with 0.25. So it's harder for us to guard against derailment. A second reason for packing is to get the vehicle at the correct height. Every vehicle has to sit within its kinematic gauge, and if it ever moves out of its kinematic gauge, then it runs the risk of side-swiping a passing train, and this can result in car body damage. We also pack to maintain bump stop dimensions. We don't want our bump stop dimension to be too small, otherwise these two surfaces hit each other too quickly, and that would give rise to some rough riding. But again, we don't want this to be too high either, because this stop also provides some protection of the spring in case of a wheel overload. So we have to get those clearances correct. And unfortunately, all vehicles have centres of gravities which generally do not lie on the centre line as they should do. They tend to be offset one way or another, and we might well pack this to counteract this offset of centre of gravity. And we've also got to cope with the body to bogie connections, which means that when you start playing around with one end of the vehicle, the one bogie at one end of the vehicle, then you're inevitably going to be changing what's happening at the other end of the vehicle because of these body to bogie connections. Now, traditionally, a trial and error approach is used, and this involves weighing the wheel loads, measuring some heights and the gaps, and then adjusting the packing, and then checking by weighing the wheels again, measuring the heights again and the gaps again, and you'll probably have to adjust the packing again, and you may have to do it again and again, and you'll very soon find yourself chasing your own tail, or feeling like you're chasing your own tail. But you do get better as time goes on, and what I've seen happening is people develop black art techniques. But I think when these are stood up to engineering scrutiny, they often just mask confused thinking. ExcelCalcs have come up with a method of predicting the optimum packing dimensions. So the procedure is the same. We weigh the wheels, we measure heights, and we measure the gaps, but we pop those then into a spreadsheet, and that tells us what the optimum suspension packing is going to be. The calculation method is based on partly analysis and partly measurement techniques. But what it means is that we can get things right first time. When you get things right first time and compare it to your trial and error method, then we found that we reduced wheel packing time down to 17% of the time it took using a trial and error procedure. Now, this provides a compelling financial motive when you consider it over a whole fleet of vehicles. So there's some big money savings to be made here. And not only that, if we continue to weigh our vehicles from time to time, and if you send the results through to us, then we can monitor those, and we can see how the wheel weighs change over time. And our software will assess the results and provide us with alerts, and it will alert us when we are getting closer to that risk of derailment. Now, we'll not only do this, providing the alert, the stop-go alert, but we'll also provide you with a checklist of possible corrective actions, because the wheel imbalance might be deteriorating because wheels are wearing unevenly. It might be because there's a faulty suspension element, so that's steel springs or rubber elements, or even a bearing. Or we can just provide you with more a new set of repacking dimensions so that you can go away and rebalance the vehicle. So, WeighWell and ExcelCalcs forming a partnership. WeighWell, providing proven and portable wheel weighing solutions over a worldwide rail industry, getting together with ExcelCalcs, who spread expert knowledge contained in their engineering spreadsheets, and together we'll be providing the railway industry with a way of providing safer and more cost-effective rail services. Thanks very much for listening.